Okay, so in last class, we discussed about the concept of the nuclear reactions, right? Nuclear fission and nuclear fusion
Yeah.
reaction, and in which we also discuss a few examples of equations that if equations was given, so how to balance them, just count the number of proton and number of neutrons on the both sides. So in that way, you can easily balance your equation, and they will not ask to complete the equation or write the equation by your own. In old past papers, they ask that, but now we know that there are different multiple process of nuclear reaction, so they will not ask about the complete equation to write the complete equation. They only ask about, let's suppose one element is missing, so complete the number of proton and number of nucleons in that. So just like balancing the equation, you may count the number of protons and nucleons in the product and in the reactants, right? And today we are going to discuss about the nuclear power plant, or we can say the nuclear fission reactor. If you remember, we discussed the same setup in work energy power chapter, right?
Yeah.
But only the difference is that in work energy power chapter, we discussed the whole concept with geothermal energy because
This time we used uranium.
yes, in this time we are talking about completely nuclear reactions. So that's why we are talking about nuclear reactor. And the basic mechanism is very simple because you already know that we make steam from heat and that steam helps the turbine to move and that generates electricity. Only the initial part, the fuel we are using for the reaction is different. At that time, we are using geothermal energy as a fuel, and this time we are using a complete nuclear fission reaction as a fuel. You can see that whole setup in the diagram, and in this diagram, the first part is different and rest of the part remains same, that we are making a steam, that steam helps the turbine to move, and finally we are getting electrical energy in the end, and again that steam cools down and turns into water and moves back into the reactor, and this process will continue so on. But the problem in this reaction is this, because you all know about fission reaction, right? Fission reaction means to split heavy nucleus into small nuclei. And if you remember, we also discussed that in nuclear fission reaction, once it starts, so it will continue to split into multiple neutrons, right? And that neutrons further strike the nucleus and it works like a chain reaction. So this is the reaction of fission that we discussed in our last class. So we just strike one neutron and that is split into multiple other elements, and plus neutrons are also emitting during the reaction. So that neutrons further continue the process of fission reaction until it completes the half-life and the complete atom or complete nucleus of that atom decays, right? So that is the problem, that how to control this reaction, because once this reaction starts, so it will continue. So in this reactor, we have to control that reaction by our own. That let's suppose if we want to stop the reaction, so how to stop that, and if we want to start it again, so how to start it again by our own. So the main purpose is to control the reaction, because nuclear fission is not difficult to perform. Only the problem is to control that reaction, right? So
Yes, sir.
basically, in this reaction, we are generating electricity by mean of fission reaction. And in past paper, most of the time they usually ask about the components, because there are two important components in this nuclear reactor which are completely different from the others. Because again, the same, we need to know about how to control the reaction. So that is the most important thing as compared to generate the electricity or start the mechanism. So you
We
can see,
use rods, right? Some
yes.
carbon rods or something. Yeah.
So here you can see there is a control rod, and uranium fuel element, reactor core, and a molten sodium or liquid water, which is used as a moderator. So moderator and control rods, these two components are very much important, and these two components are completely different from the other reactions to generate electricity. So let's suppose if we discuss about these steps to generate electricity. So the very first important thing is we are using uranium fuel elements. Like you can see these red rods actually shows you the concept of uranium rod. So these rods are made up of uranium. So basically, to start the reaction, we have to strike a neutron on the uranium rods, right? So fission reaction will start. So the very first step is uranium rods are struck by neutrons to initiate fission reaction. So this is the very first simple process to start the fission reaction. We have to strike neutron on the uranium rod to start the process, right? And the second thing is it helps to generate a very high amount of thermal energy. So that thermal energy or that heat is carried to water using molten salt, where water turns to steam. And after making up the steam, the next process, you know that that steam drives the turbine, and that turbine helps to generate the electricity, right? So process is not much very difficult. So basically this steam is used to drive the turbine which drives the generator to make electricity, right? So this is the very simple process, and further the rest of the steam is then condensed back into liquid form by using cold water, and then it pumped towards the reactor again to continue this process in a cycle form to generate electricity. Okay, any confusion? And let's suppose if we
No, sir.
consider a graphical animation of this whole process, so that will further help you to understand how this reaction take place and how these control rods and the moderator, that is the water itself, helps to slow down the reaction. Because again, the same problem we all know that this works like a chain reaction, and to control this chain reaction we need something to control this reaction by ourselves. because if we are not able to control the reaction, so it will start automatically once we just provide the fuel to it, and we are not able to control it, and we are not able to make the specific amount of electricity. It will be generating by its own, and we are not able to control it, and we are not able to store it according to the requirement. So this is the animated diagram for the nuclear reactor. You can see on left hand side there is a complete nuclear tank, we can say that, which actually providing the fission reaction. And from this fission reaction, you can see that in the central container there is a water which is converting into steam. And this is actually showing you the old method of using the coal to make electricity that we discussed in the chapter of work energy power. So basically, in this process, these are fuel elements. Fuel elements means uranium rod, right? And for moderator, we are using water. And plus, if we consider the control rods, so these are the control rods and these are made up of different material, right? We will also discuss that what are the materials that we use to make the control rods to control this whole setup. And why we are using rod? We are using rod. Let's suppose if you require very high amount of, if you want to generate high amount of electrical energy, so we input or we immerse multiple rods at a single time, right? And if we want to generate very less amount of electricity, or if you want to generate few amount of electricity, so you immerse only few rods in it, right? Because if you are using multiple uranium atoms over there, so definitely fission reaction will be more stronger. And if we are using less rods, so it means there will be less quantity of uranium atom, and that will generate less amount of electricity because fission reaction will be slowed down. And this is moderator, normally water. And what will be the working of the moderator, we will also discuss that. Okay, now you can see these three particles are simply neutrons, right? And these neutrons are going to strike the uranium rod, and you can see when it strikes with the uranium, so according to fission reaction, it starts to start a fission reaction, and it splits into multiple neutrons from the uranium nucleus, right? It is just like this fission reaction. So you can see once neutron strikes with the rod, it is converts into multiple neutrons. This is the definition of fission reaction again. You can see it strikes the nucleus, then it further splits into elements, plus the number of neutrons will be adding up in the reaction. So this is the normal fission reaction that takes place. Now, what is the working of moderator? It means water, and there are two possibilities. Either we use simple water that we use in our daily life, H2O, or heavy water, right? It depends upon the usage that how much electricity we are going to make. So you can see when neutron starts to move from one point to any other point to strike the uranium rod. So this D2O means this is heavy water, right? Deuterium, we discuss about the isotopes. So deuterium and tritium both are the isotopes of water. So basically it helps to resist the path of the neutron or want to resist the speed of the neutron. So this will help you to slow down the nuclear reaction. Okay. And let's suppose if we use simple water like normal water H2O, so that will also help you to do the same thing like this. It will also help to resist the path of the neutron to slow down the neutron. So your process will automatically slow down. And now let's discuss about the concept of the control rods. What is the working of the control rod? Why these rods are known as control rods? So you can see there are multiple number of neutrons, right? And you know when multiple neutrons strikes the rod at a single time, so definitely your reaction will be more faster as compared to the initial stage. So if let's suppose if you want to stop the reaction or if you don't want to generate more electricity, so what we have to do? So then control rod will help you to slow down or to stop your reaction. So basically, control rods are not all the time into the container or into the nuclear reactor, right? It depends upon the mechanism that if you want to immerse those rods, so then your nuclear reaction will be slowed down. And if you just make those rods move away from the reactor, so your reaction will be faster, just like the normal fission reaction. So when you immerse the control rods into the reactor, so you can see neutrons are stick on the control rods, right? So now they are not moving just like the previous. You can see the motion of the control rod, the motion of the neutron is stopped because of the control rods. They are not moving freely just like the previous state. Okay. And there are two different materials. Either they make these control rods with cadmium or boron. So it depends upon which material we are using. And if you just remove those control rods, so again, this reaction will be faster, just like the normal nuclear fission reaction. And if you again insert those rods, so that will again absorb the neutron. So neutron sticks on the control rod and they are not moving. So that will help you to control your reaction. And you can see very high amount of heat is generating, and that helps the water to convert into the steam, and that steam is completely moving through the pipe to the turbine, and that turbine will help you to generate electricity, right? And further, you know that uranium is radioactive material, so it will also affect the surrounding. So that's why if you focus on the left hand side on the reactor, so they also mention that we are using concrete walls, so radiations will not coming out from the reactor in the atmosphere. And second, reactor core. Reactor core means the container which we use to make for the nuclear reactor. And the next part is the heat exchange. Heat exchange means the steam is going to run the turbine, and then the rest of the steam will be cooled down, condensed, and convert into the water, and again pumped towards the nuclear reactor to use that water again to make further
So
steam.
what's the difference between a uranium
Mhm.
power thing and then the geothermal?
Basically, you know that geothermal is like dependable, right? It will not help you to generate very high amount of thermal energy, right? Because you know, let's suppose if you are at a surface or you are performing that experiment on such a land where thermal energy or the temperature of the earth is not much very high. So the first problem is you have to set up your electricity generator very deep into the earth, right? To get the high temperature. And that process is very slow. And let's suppose if your surface or the temperature of that surface is not much very high, so you are not going to take very high amount of thermal energy from there, right? Because we are not going to move towards the core, because core is in the center. So definitely we dig into some meters under the ground to get that geothermal energy. And definitely when we are setting up all the pipes and all the things, so definitely they also absorb thermal energy. So you are not getting a very high amount of thermal energy in a particular form, but in nuclear reaction you are getting very high amount of thermal energy from a very single experiment, and you can perform that experiment anywhere, right? It is spontaneous, means there is no effect of external condition. So this is the advantage of using this nuclear reaction as compared to geothermal. And this process will also help you to generate very high amount of electrical energy as compared to any other process. So this process is very fast as compared to the other, and that will help you to generate very high amount of thermal energy, and it is not depending upon any type of external conditions. So this is the advantage and this is the difference of nuclear fission reactor as compared to any other reactor to generate electricity. Just like if you take the example of windmill, we discussed that wind will also help to generate electricity, but that is also dependent on the speed of the air molecules. If the speed of the air molecules is not high over there, so you are not going to generate very high amount of electrical energy. And for that, you need to set up a specific open area for that. So you will get very high speed wind or high speed of the molecules to strike the propeller and move them and to generate electricity. So you are actually depending upon the external factors. But in nuclear reaction, we are not depending on any external or any other factors. We are just depending on the reaction, the rate of reaction, and how to control that. So this is the simple process. And in the different movies, just like the Chernobyl basically is the name of the city where they set up a nuclear power plant, and they already have one power plant, so they are testing the new power plant, nuclear power plant basically. So to test the maximum level of that nuclear power plant, they just immerse multiple uranium rods into the water to make the reaction faster. But again, the same problem, they are not able to control that very high amount of thermal energy or the fission reaction, because they immerse multiple rods at a single time to just fast their reaction to get the results quickly, and they will not able to control the reaction at that time, and that explodes the whole nuclear reactor, and those radiations will add up into the atmosphere, and that completely spoil their whole nuclear power plant. Okay, so any confusion in the process of nuclear fission reactor? So after the steam is used to drive the turbine, which drives the generator to generate electricity. So the next process is the steam is then condensed back to liquid. Using cold water in the condenser, and this will continue your process of nuclear fission reaction just like the same. And further, if we discuss about the control rods, so as you already observed that control rods just absorb or just all the neutrons stick on the control rod, so that will help to slow down your reaction. So these rods are used to control the speed of reaction by adjusting the quantity of neutrons in the water or in the reactor. Clear? Any confusion?
No, sir.
And let's suppose in exam if they ask about the moderator also, that what is the role of moderator in the nuclear power plant. So basically this moderator will also help you to slow down the neutron in nuclear reactor. So basically, in control rod, you know that they actually absorbs the neutron, right? But moderators are not able to absorb the neutron. Just like in the video, you know that they only help to slow down them, right? So their momentum will decrease or their speed will slow down. But moderators will not absorb the neutrons that are moving in the nuclear reactor, right? So one more important thing, the material which we are using in moderator have a small atomic mass. So that is absorb the neutron. Because if we are using the moderator which completely absorbs the neutron, so it means that the new moderator completely absorbs the neutron because we are performing that experiment with water or the heavy water. So it absorb all the neutrons and nuclear fission reaction will not carry forward. So that's why it not helps to absorb the neutrons. It only slow down the neutrons, which actually performs the fission reaction, right? So this will
Yes,
help
sir.
you to maintain your reaction or to control your reaction by your own, that how much reaction you want to make over there and how much electricity you want to generate from that specific reactor, right? So this is the concept of nuclear fission reactor, and I think it is not much very difficult because we already discussed about reactors in work energy power section.